Okay, so we are going to talk about the tutorial problem in Module 5. Basically, these problems are designed based on the Module 5.4.3. This problem is not specifically designed for studying the Module 5, okay? Okay, the first problem is the rounding error analysis. Tutorial 5. Okay, let me first copy the tutorial given code. Subquestion A is a mat2, copied from the mat1. And first column of the mat2 is rounded toward the negative infinity. Okay, so let's see the function. So what is the rounded toward the negative of infinity? So floor, right? Okay, so first the column, floor, like this, right? So you can put the array is a vector or a matrix onto the built-in function, right? Okay, so this one is the A. B is the mat3, is copied from the mat2. Second column is then rounded to the nearest integer toward 0. That is toward the nearest integer toward the 0. That is the fixed, right? Okay, so that should be 3, right? Fix the mat3 second column, right? Okay. C is the mat4, copied from the mat3. Mat4, then rounded to the positive infinity. Rounded to the positive infinity is a cell, right? So, what is the third column, right? Third column is the cell mat4, third column. Okay. What about the D? So round error which contain the absolute value of the difference between element in M1 and element M4 is basically we are going to find out the rounding error by subtracting the mat1 from the mat4. Okay, so we can round the error is the subtract this M1 and 4, then apply absolute function, right? So what about the E? E is the error means it's the mean of each row of the round error. Okay, so we can use the min function, round error, but here mean of each row. So what is the direction? It's a horizontal direction. That's why it should be 2, right? What about F? F is error sum, which determine the sum of all value in the round error. So just the round error all or error sum. Is this sum round error reading all value using the linear indexing. Okay. G is the adder max which determine the maximum value in each row. So max round adder then 2. Is it correct? No, right? This dimension input argument should be located in the third element, third argument, and then put the empty bracket here. That is the syntax for max or mean. Okay. H is the error mean which determine the minimum value to each column, right? You can simply do like this, or error mean round error empty bracket and 1. Okay, it's easy, right? This question is just to review the module 5, the built-in function and their usage. Okay, so take a look at this slide. Okay, so run. Okay, so line 8. Oh, there should be met 1, right? No error. Okay, so copy this code and then paste here, then run script, no error, submit. Okay, so what is the issue? mat2 is incorrect value. mat2 is the incorrect value. Why? Okay, let me check this. Okay, the next problem is a baseball stat. This problem is ask you how to replicate a built-in function using loop and then selection statement. Okay, so we are going to use the stat matrix that includes the stat for the 4 baseball players. The item is the AB, single, double, triple, home run, strikeout. Okay, there's a 6 item. That's why the stat matrix is a 4 by 6. Okay, let's solve the problem A. Problem A is the compute the hits. Hits are the summing up the single, double, triple, and home run. The values are located in the second, third, fourth, and fifth column, right? Okay, so create a variable hit A which calculate the amount of the hit each player. Okay, and so this example, for example, in the row of the stat, that is the stat for a single player, right? So we are going to adding up the value between the second column to the fifth column. Okay. This problem is solved by using the loop statement without using the built-in function. Okay. Good. Let me first copy this code. Okay. Then okay. Hits A is 0, 4. Okay. So if you see this matrix, you can easily, perform the summing up in the horizontal direction using the sum function, right? But the problem A is we cannot use the sum function. So how to design this? How to replicate the sum function using the loop structure? So if you see this slide, so then here's as a vector 1 is summing up the matrix in the horizontal direction, right? So this we replicate the exactly same the operation of the summing up in the horizontal direction. The difference is this one is we are adding up all the value in the row direction, but in this case we are only summing the value from the second column to the fifth column. Okay. So how to design the loop structure? So let's this one here. Okay. So we designed the double loop structure. II is the player ID 2D 4, right? This is their 4 player. JJ is the stat, okay? Stat item. So how to set the range to 2 fifths, right? Because we are going to read the value at the second column to the fifth column, right? And then hits A at the ith player. We can just the ith player plus we are reading the stat item. Stats II and JJ, right? You see this? The structure is exactly same, right? This one and this one, right? So only difference is that this one is a range of the column range is a 1 to the end, but this one is we are only adding the value at the second column to the fifth column, right? So we are designing the loop structure like this. Okay. What about the B? B is much easier, right? So hit B is this sum stats. I mean here this sum is just a function to adding all the value, right? So in this case we just read the value from the second column to the fifth column so that we can use this sum function. So all the column to the second to the fifth, and dimension is the horizontal, okay, like this. So in this slide we are adding all the value in the row direction, right? But in this case we would like to sum the value from the second column to the fifth column. That's why we're reading the value all column from the second column to the fifth column, and then adding the all value in the horizontal direction. Okay, makes sense. C is the batting average, is that amount of hit each player has divided by the total number of the batting attempts, that is AB, right? So create a row vector, okay, bat average, so row vector 1 by 4. So it includes a batting average of each player. Okay, please do not use the loop statement. Okay, so here, so amount of the hit each player has divided by the total number of the batting attempt. Okay, so we already find out the hit value, right? We just simply hit B is divided by number of the batting attempts, right? The value in the AB, right? So we are simply, okay, we don't need to do the initialize. We are just directly hit B. So dot division, right? Dot division stats first column, right? In this case, it should be the dot division, right? This one is the element-wise division. Okay, so that could be bat average, but here bat average is the row vector, right? So that's why we are going to transpose the bat average at the end, right? That become a 1 by 4 vector, row vector. Okay. Make sense? So what about the D? D is to create a variable HR max, which is the maximum number of home run in stat. Okay? That's a simple, right? It's a max. Where is the home run stat? Home run in stat. That is the fifth column, right? So we can simply stat fifth column. Okay. In this case, the fifth column is a vector, so they're picked the maximum value among all elements, right? Okay, good. What about the E? E is the create variable HR leader player numbers who has the most home run in data stat. Okay. That's a simple, right? You can just use this syntax. This one. Okay. This one. So we just find out the ID is a player number. Player number is just a row index in stat matrix, right? So you can just simply max stats 5. Okay. Makes sense? Okay, so what about the F? F is you're going to solve the same problem of the D and E without using the built-in function. Okay. The resulting value assigned to the HR max F, HR leader F. Okay. So we need to use the loop statement in this problem, in this subquestion. So we first initialize HR leader F is 0. Okay. How to find out the max value? We'll learn about that right here, right? See this? So first, we already know that there are 4 players, right? So we set the range to the to the 4 player, right? And if the home run II is a home run is a 5th column. Okay, so for first the max fell. No. Let's initialize this home run is the stat for first player. Okay, and then this one is set to the first player. Okay, I mean the only difference is this part. Okay, that's the ID, it's the location. Okay, so here is the stat is the HR max F. We need to assign the stat for the II player, right? HR max F to become a stats. And how to find out the leader. So how to assign this one? That should be II, right? That's it. Do you understand how to utilize this base code to find out the max value as well as the ID? ID is simple. You just put just one line here. So we are assigning those IDs when the current value is larger than the current maximum. Okay. If you don't understand this part, so please watch the lecture video on this part. Okay. Okay, good. So let me check before submitting this code. Let's run first. Let's print out the HR max. Okay. So let me use the printf. Okay. So percentage D is the HR max F. HR max, HR max, and HR max F, right? So not VS. Same. Okay. Then like this. Okay. Then here HR leader, HR. Okay. Run it. Oh, I didn't save this code. TUT05 baseball stat. Okay, what is the header? Hit A. Oh, this one is a hist A, right? Okay. Run it. Run it. So those two values are same. Okay. I'm just showing that this is the one way of the checking the value. Okay, good. Just copy this code. Copy this code. And then paste here. Okay. Run script. No error, submit. Okay. Good. Okay. Next problem is a built-in function. Store TUT05 built-in function. Okay. It looks a very simple problem, right? Okay, so let me first copy this code. Okay. Okay, so A is the vector 1 is the row vector contain the maximum value in each columns of the mat2. Okay, so we just simply mat2. So default direction is the column direction, right? So you can just simply max and put your input matrix. Okay, B is the vector 2 is the minimum value in each row. So we just mat2 row direction, but in the min and max function, we should put the empty bracket here, right? So, but here vector 2 is the row vector, but the output is the column vector. That's why we should put transpose, okay? C is the value 1, which is the maximum value of the all mat2. So we can simply value 1, max and mat2, empty bracket and all. That's why I normally, I often use this syntax, because I'll avoid this mistake to put this empty bracket. Okay. D is the value 2. The scholar contains the row index of the minimum value of the first columns of the mat2 is located. So just the minimum value. mat2 first column, right? But value 2 is the index, so we need to use this syntax. Where is it? This syntax, right? The min and max are exactly same syntax. Use the exactly same syntax. Okay, so we put the like this. Okay. What about the A, B, C, D, E is the vector 3, which is the 4 by 1 column vector summing up all the each row. So we already did the practice of the using the sum function, right? So mat2 row direction is the second. So horizontal direction is a 2, right? C, D, E, F is a value 3, is a scalar variable containing the sum of the first columns of the mat2. Sum mat2 first column, right? Okay, so when you're adding up the value in the column, the one single column vector or row vector, we don't need to specify the dimension, right? Because in the input is a vector, they're summing up all the value. Okay. Fg is a value 4, which is a scalar variable contain the sum of the all value. Okay. mat2. Kg is the summing up all value. So sum mat2 reading all value, right? Okay, H is the value 5. It's gonna contain the sum of all the diagonal element. Okay, how to read the diagonal element? We need to use DIHE, diagonal built-in function, right? This one, right? If you put the matrix here, they return a column vector of the main diagonal element of the input matrix, right? So maybe diagonal mat new, right? So sum diagonal, okay, like this. Or you can just simply put this function, put this part directly into the inside of the sum function, like this. Okay, I is a vector 4, which is a 1 by 5 row vector, contain the median of each column in the mat2. Just mat2, right? So column is the default, right? Okay, what about the K? K is the mat3 is copied from the mat2. All columns are then sorted with the highest value in the top row and the lowest. It's like a descending order, right? So mat3 is this sort, mat3 descend, right? Because you're sorting the columns a vertical direction, so we don't need to specify the direction, right? So let's see. Yeah, this one. Okay, this is syntax. Put the input matrix and then direction. Direction is a descending order, right? Make sense? Okay, K and L, right? mat4 is copied from the mat2, and then third row is then sorted from the lowest on the left and the highest on the right. Okay, mat4 third row, right? Third row. So how to sort? mat4 third row. So where's the direction? So left side is sort third row lowest on the left is ascending order. So we don't need to put any the second argument here because ascending order is a default, right? Run it, no errors, so let me clear this part. No errors, we copy this. Run it. Error, submit. Okay, value 6. Value 6 is the... Oh, J. Oh, there's no J here, right? Okay, J is the value 6, so which is a scalar variable and contain the mean of the all value. So you can simply like this, right? Okay, so we copy this. Here, run. Okay, good. Okay, next problem is find the second maximum. Tutorial 5 second. Find the second maximum. Okay. Please write a script to find the second maximum element of the vector 1. Okay. So how can we find the second maximum? Can you solve this problem using the sort? Yes, you can, but remember that the maximum value, the number of maximum values may not be 1. I mean, they could have a multiple maximum value. Because the 100 values are generated from the -2 to 20, right? The same values appeared over and over. It's the maximum value as well, right? Okay, in this case, there are lots of the way to find out the second maximum value. You can use the max function, you can use the sort function, or you don't need to use this built-in function to find out the second maximum value. But in this case, I just use the sort function. So the step 1 is the sort factor 1 in a descending order. Okay, and that's named as a sort factor 1. Okay. Then step 2 is the construct the loop structure. A loop structure from the loop structure to read the value in the sort factor A. Read and compare, read the value to structure to read the value and compare with the maximum value. Okay, I'll say first maximum value. Okay, so in this case, the issue is this one. We are sorting the value in the vector 1. First element, if you know, sorting this value in the descending order, the first element should be the maximum value. What about the second element? It could be the first maximum value or the second maximum value. So we don't know, right? So we make the loop structure and then read the value from the second one and third one in order, and then compare with the maximum value. So maximum value is the value in the first location, right? And then if they are not the same, that is the second maximum. Okay? So step 3, if they are different, the corresponding value is the second maximum. Okay? So first we are sorting the vector 1, the descending order. Okay? Then we make the loop structure is equal to 1. No. We are comparing the value from the second one, right? So to 200, right? Then compare these two values. If the second value, not second value, ith value, sort ith value is not the same with max of the first maximum value, right? Then your max 2 become a sort vector 1. Then what are we missing? Break, right? Okay. Do you understand this code? Okay. So our goal is to find out the second maximum value. Okay. So if you know the numbers, the values are not overlapped, you're sorting the value in the descending order. Second element is, should be the second maximum value, right? But the problem in the vector 1 is the values are overlapped. So there are many the first maximum value. So we first sorting the vector 1 in the descending order. Then we know the maximum value, right? That is the value in the first location in the sorted vector 1. And then compare this compare the rest of the value with the vector 1 by 1 in order. To compare the value in the second location with the maximum value, third location with the maximum value. But if these values are not the same, so for instance, if they're same, meaning that there's more than one maximum value, right? But if you compare this two value in order and suddenly they're not the same, that value is the second maximum value, because we are working with the sorted vector 1 in descending order. Is it clear? Okay. So that's it. So in this case, once we find out the second maximum value, we don't need to continue this process. That's why we use the break here. Okay. Run it. Oh, sorry. Sort the vector. Okay. Where's the sort of vector? Oh, here. Vector 1, right? Run it. Okay. So let's check what are the inside of the sort vector 1. Okay. Sort vector 1. Oh, luckily there's only the one maximum value. Okay, that's why max 2 become a 19, right? Let's run again. Okay, let's run again. Run again. Okay, in this case, there are 4 maximum values. Okay, so in this case, let's what is II here? 5, right? When they're reading the fifth value, that is 19, right? That is not the same with the first value. That's why the condition statement is true. Then assign the fifth value to the max2 and then break. That's why max2, so 19 is assigned to the max2. Does it make sense? Okay. Okay, so I copy this code and then paste here. This code and then paste. Run script. No error. Okay, submit. Okay, good.